Hi there, thanks for joining me. Today we're going to talk about excess and limiting reactants. This is part of our unit on chemical reactions, and it's our stoichiometric applications to chemical reactions. So our goals for today: to deduce limiting and excess reactants, to calculate the amount of product formed once we know what the limiting reactant is, and then to calculate the amount of excess reactant left over. So really, we're going to be doing the same sorts of calculations, right? We're just going to be thinking about what they mean and what they can tell us. So let's start with an analogy. Let's say I want to make sandwiches, and my definition of a sandwich is 2 slices of bread and 1 slice of cheese, making cheese sandwiches. And I check for ingredients, and here's what I have. I have a loaf of bread with 22 slices, and I have a package of cheese with 8 slices. Well, how many sandwiches can I make? You can probably see pretty easily that the thing that's going to dictate or limit the number of sandwiches I can make is the cheese. I can make 8 sandwiches with the amount of cheese I have. Once I make 8 sandwiches, I can't make any more cheese sandwiches because then I'm out of cheese. So in this scenario, the cheese is like our limiting reactant. It's going to be the thing that runs out first. It also is going to be then the thing that says here's the maximum amount of product that you can make, the maximum amount of sandwiches. The other ingredient, our bread, is the excess reactant. We have more bread than we need to use up all the cheese, so some of it's going to be left over. And we can even figure out how much is going to be left over, right? If I make 8 sandwiches, that's 16 slices of cheese. And so I am going to have a total of 6 slices of bread left over. So these are essentially the same sorts of calculations we're going to do with our limiting reactant scenario. So the definition of the limiting reactant is it's the reactant which is used up first. Right? It is going to determine the maximum amount of product that you can form. So in other words, whatever amount of limiting reactant you have, that's going to tell you what your theoretical yield is, using some of our older vocabulary, right? And it also determines the amount of the other reactant which is consumed. The amount of bread we needed depended on the amount of cheese we had, right? So the reactants are tied together too. So the excess reactant, right, whatever the excess reactant is, you have more reactant present than is needed to fully react with the limiting reactant. So some of that's going to be left over. So if you look at the little chairs and people down there, right, in this case, the limiting reactant is the chairs. Once 4 people sit down, we will run out of chairs, and so we will have excess people. There's 1 person left over. Same kind of idea. Okay, let's jump in and work through a problem. So the thing about limiting reactant problems is they look like this, right? We're given 2 grams of ammonia, or I'm sorry, 12.2 grams of ammonia. That's one of our reactants, and 15.4 grams of oxygen. And we want to find out which of those 2 is the limiting reactant. Now, because atoms are all different sizes and we have the mole ratio involved, right, we can't just look at which one we have more grams of to tell what the limiting reactant is, because a gram of ammonia and a gram of oxygen aren't going to cancel each other out or work together in that ratio. The ratio depends on the way the particles are reacting in the balanced equation. So there's a lot of possible ways to do this sort of problem. And so the one that I'm going to do, it looks like this. The first thing I'm going to do is I'm going to take both of those grams and convert them to moles. So I have 12.2 grams of NH3, and I'm going to convert that to moles. So 1 mole of NH3 is 17.04 grams, and that works out to be 0.716 moles of ammonia. For the oxygen, I'm going to do the same thing, 15.4 grams of oxygen, convert it to moles. 1 mole of O2 is 32.00 grams. That equals 0.481 moles of oxygen. Right, so I know how many moles of each of those I have, and now what I'm going to do is I'm going to convert one of those to moles, one of those givens, to the other. So if I take my 0.716 moles of ammonia, and I use my mole ratio to convert it to moles of oxygen, I'm going to use 4 moles of ammonia for every 3 moles of O2. That tells me I need 0.537 moles of O2. Okay, now from this, I have enough information to determine the limiting reactant. So I'm going to compare this and think about what it means. What I've figured out here is if I want to use all 7.16 moles of ammonia, I need 5.37 moles of oxygen. But when I look up here, how many moles of oxygen do I actually have, right? This is what I need. This is what I have. Well, I don't have enough oxygen to fully react with all the ammonia. So that tells me that the O2 will run out first. Oops, first. I can't spell. Let's try that again. F-I-R-S-T. So if the O2 runs out first, that means that O2 is the limiting reactant. Right, so we're going through our processes and we're thinking about what the numbers mean. Now, once I've figured out what my limiting reactant is, right, I've identified oxygen as the limiting reactant, then I know that ammonia is the excess reactant. What I can do is I can answer this question. What's the theoretical yield in grams of nitrogen? So I'm going to start always with the limiting reactant and then use that to figure out how many grams of nitrogen I'll get. Now remember, on the last slide, I already figured out how many moles of O2 I have, so I'm going to start with that, 0.481 moles of O2. Okay, well, the relationship between O2 and nitrogen is that I get 2 moles of nitrogen for every 3 moles of O2. Then I can convert moles of nitrogen to grams. 1 mole of N2 is 28.02 grams of N2. And so that works out to be 8.99 grams of N2. So I've taken my limiting reactant. Once I identify my limiting reactant, that's going to kind of be the starting point for everything. And I use that to figure out how many grams of a specific product I can make just by doing the stoichiometry. Now, the very last thing that I could ask is, this is kind of like asking, I know oxygen is the limiting reactant, and I know ammonia is the excess reactant. What I'm asking here is how many grams of this will be left over, right? What mass of excess reactant is left after the reaction? So will be left over. So this is always the one that's a little bit tricky. To figure out how much of the ammonia is left over, the first thing we have to do is figure out how much we're going to use. Right? So the way we'll do that is we'll take our limiting reaction and we'll turn it in to grams of excess reactant. So starting with our moles of limiting reactant, 0.481 moles of O2, let's turn it into grams of ammonia. So that is 4 moles of ammonia for every 3 moles of O2, and then I can convert to grams of ammonia. 1 mole ammonia is 17.04 grams of ammonia. And that equals 10.9 grams of NH3. That's how much we're going to use up. Right? The question asks, though, how many grams are going to be left over after the reaction. And so to get that, I have to look at the original problem and see how many grams I was given to begin with. That was 12.2 grams, right? That's the amount we were given. And then the amount that we use up is 10.9 grams. And so that means that 1.3 grams of ammonia is left over. So once you determine what the limiting reactant is, that's kind of the starting point for everything else that you'll be asked to do. Okay, now let's do one more example. Here we're given a gram of hydrogen and 9 grams of oxygen, and we're going to determine some stuff based on that equation. The first thing is, what's the limiting reactant? All right, process again. Take both of your given grams and convert them to moles. So let's do that. 1.00 grams of H2, 1 mole of H2 has a molar mass of 2.02 grams. That works out to be 0.495 moles of H2. For the O2, I have 9.00 grams of O2. 1 mole of O2 is 32.00 grams of O2, and that works out to be 0.281 moles of O2. Okay, once I get moles of both reactants, I'm going to pick one and I'm going to convert it to the other. So I'm going to take my H2 and I'm going to convert it to moles of O2. So 1 mole of O2 for every 2 moles of H2 from the balanced equation gives me 0.248 moles of O2. Okay, so what I'm saying here is, if I want to fully react with the H2, I need 0.248 moles of O2 needed to fully react the H2. How much? So that's how much I need, but this is how much I have. I have more O2 than I need. So if I have more O2 than I need, that means the O2 is going to be the excess reactant, and our limiting reactant is going to be the H2. Right, so H2 is, I've identified that as the limiting reactant, and anything else I do, I'll always start with H2. So I can ask this question: what's the theoretical yield? The thing that is yielded in this reaction, the thing that is made in this reaction, is water. It's the only product. Yields are always products. And so when I ask what's the theoretical yield, what I'm asking is how many grams of water will form. So question mark grams H2O, how many will I get? So to find this, I start with my limiting reactant. I already have moles of limiting reactant, so I do 0.495 moles of H2, and I'm going to convert it to water. So my first step, mole ratio, I get 2 moles of H2O for every 2 moles of H2. That's from the balanced equation. And then once I have that, I can say 1 mole of H2O has a mass of 18.02 grams. And that will tell me that I will get 8.92 grams of H2O theoretically from this reaction if all of the hydrogen reacts. Okay, and then the last thing, how many grams of excess reactant are left over? So if hydrogen is the limiting reactant, we know oxygen is the excess reactant. So the first thing we have to do is find out how much of the excess reactant we use. So I'm going to convert my moles of H2 to grams of O2. So I have 0.495 moles of H2 I get or use 1 mole of O2 for every 2 moles of H2, and then that 1 mole of O2 has a mass of 32.00 grams. And so that works out to be 0.792 grams of O2. That's how much gets used. But how much is left over? Well, we started with 9 grams. So I do 9 grams minus 7.92 grams equals 1.08 grams of O2 left. And that's the end. And that's all I have to say. So have a great day.